Episode 7, titled 1.1 Map Data Structures, Structured Tables, JSON, and Unstructured Content, the focus is building a simple map of structure and understanding how that map changes storage, search, analysis, and governance decisions. The CompTIA Data Plus DA0-002 exam frequently describes data in everyday forms, and the correct answer often depends on recognizing whether the data is structured, semi-structured, or unstructured. Structure is not just an academic label because it controls how easily data can be queried, how reliably it can be joined, and how much effort is required before analysis can even begin. When structure is misunderstood, the wrong tool or technique gets chosen, and the scenario quickly becomes messy in a way that is hard to fix later. The aim here is to make structure classification feel automatic so that a learner can hear a scenario and instantly know what type of data it involves and what that implies. Structured data is best defined as data that fits into fixed columns and rows, where each record follows the same schema and each field has a predictable meaning. A structured table usually has a defined set of column names, and each row represents an entity or event that can be compared to other rows because the same fields exist in the same positions. This predictability makes structured data easier to query and aggregate because filters and calculations can be applied consistently without first discovering the shape each time. Structured data also supports clean joining between tables when identifiers and keys are consistent, which is why it is central in many operational and reporting systems. In exam stems, structured data is often signaled by language like table, column, row, schema, relational, or database, and those signals usually point toward techniques that assume consistent fields. Semi-structured data is best defined as data that includes tagged or labeled fields, but allows flexibility in what fields appear and how they are nested. JSON is a common example because it stores key and value pairs and can include arrays and nested objects, which means one record might have a field that another record does not. The tags, meaning the keys, provide structure because they name fields explicitly, but the flexibility means the overall shape is not as rigid as a fixed table. This flexibility is useful when the data evolves over time, such as when applications add new attributes or when records represent slightly different kinds of events. The cost is that analysis often requires a mapping step where keys are selected, paths are identified, and nested structures are flattened or separated. In exam language, semi-structured data is often hinted by words like payload, document, nested, attributes, fields, or key value. Unstructured data is best defined as data that does not come with a consistent field layout that can be treated as rows and columns without interpretation. Common unstructured forms include free text, images, audio, and video, where the primary content is human meaning rather than machine-ready fields. A text document can contain valuable information, but the information is embedded in sentences and paragraphs rather than in named columns, and an image contains pixels rather than explicit attributes. Audio and video often include speech, scenes, and events, but those elements are not explicit fields until they are extracted through some method and validated. Unstructured data can still be analyzed, but analysis usually begins with interpretation and feature creation, which is very different from running a simple aggregation over a table. On an exam, unstructured data is often signaled by words like notes, comments, email, transcript, picture, screenshot, recording, or footage, and those signals point toward extraction and classification ideas rather than direct tabular queries. Search and analysis differ across these types because the amount of upfront work required changes dramatically. With structured data, search often means filtering and joining using predictable fields, and analysis can move quickly into grouping, summarizing, and calculating metrics. With semi-structured data, search often means selecting keys and traversing nested paths, and analysis often begins with turning flexible records into a consistent representation for the question being asked. With unstructured data, search often means full-text search, indexing, or pattern detection, and analysis often means extracting signals such as keywords, categories, or other features before any quantitative summary can begin. These differences matter because they affect time, cost, and error risk. And exam stems often imply a trade-off, such as needing fast answers versus needing deeper meaning extraction. A candidate who matches technique to structure usually avoids answers that assume fields exist when they do not. That matching is a professional instinct, and it shows up repeatedly in data work. A customer profile example makes the differences clearer because the same information can appear in all three forms, depending on source and purpose. In structured form, a customer profile might be a table row with columns like customer ID, name, email, status, and join date, which supports fast filtering and reporting. In semi-structured form, the same profile might arrive as JSON from an application programming interface, often spoken as API, where optional fields like preferences or multiple addresses appear only when relevant. In unstructured form, customer context might exist as support tickets, chat logs, or call transcripts, where sentiment and intent are present but must be interpreted from language. Each form can be useful, but each implies a different path from raw data to decision, and that path affects what tools and methods are reasonable. Exam questions often embed this idea by describing multiple sources about the same entity and asking what approach best supports the goal. Storage approach should match query patterns because the best storage model is the one that supports the kinds of questions that will be asked most often. Structured tables align well with frequent filtering, grouping, and joining across stable fields, especially when many stakeholders need consistent reporting. Document stores align well with retrieving a whole object quickly, especially when the object shape varies and reads tend to pull the full record rather than small slices. For unstructured content, storage often emphasizes indexing and retrieval by metadata, such as timestamps, source, customer ID linkage, and content type, because the primary content is not naturally queryable like a table. The exam signal here is usually language about the workload, such as needing fast lookups, needing flexible ingestion, or needing search across text, and each signal points toward a different storage emphasis. When query patterns are recognized, storage decisions become less about preference and more about fit. Extracting fields from JSON requires understanding paths and keys because meaning is often nested rather than flat. A key identifies a field name, and a path describes how to reach a nested field inside a deeper object, such as a customer object that contains an address object that contains a postal code value. Arrays add complexity because a single key might hold a list of items, such as multiple phone numbers or multiple events, and the analyst must decide whether to expand those into multiple rows or summarize them into a single representation. These choices depend on the analytical question because counting events requires different representation than simply storing the latest value. Exam stems often hint at this by mentioning nested data, repeated elements, or optional fields, which signals that flattening and mapping decisions matter before analysis can be trusted. The key point is that semi-structured data is not messy by default, but it does require deliberate representation choices. Turning text into features is the typical bridge from unstructured content to quantitative analysis because raw text must be converted into measurable signals. A simple approach uses counts, such as word frequencies, keyword presence, length, or the count of categories based on a controlled vocabulary. Another approach uses categories, such as labeling messages by topic, urgency, or sentiment, which allows aggregation and trend analysis even when the original content remains freeform. These features must be chosen carefully because they can oversimplify meaning, and oversimplification can create misleading conclusions if context matters. Exam questions often test whether a candidate recognizes that unstructured analysis begins with feature definition and validation rather than jumping straight to charting or correlation. The professional habit is to treat feature creation as a modeling step with assumptions that should be explained. Forcing structure too early can lose meaning because some information only makes sense when context is preserved. A support email converted into a few categories may lose the nuance of what the customer actually asked for, and a rich JSON object flattened into a wide table may lose the relationship between repeated elements. Early forcing can also create false precision, where an analyst thinks the data is clean because it is in a table, even though the mapping choices embedded bias or dropped details. The safer approach is to delay irreversible transformation until the analytical goal is clear, which reduces the chance of building a data set that answers the wrong question. This does not mean avoiding structure, because structure is often necessary for analysis, but it means choosing structure that preserves meaning relevant to the decision. Exam stems sometimes reward this caution by presenting an option that overcommits early versus an option that keeps flexibility until requirements are clearer. Governance needs become more complex when structure stays flexible, because classification and control often depend on knowing what fields exist and what they contain. In structured environments, sensitive fields can be identified by column name and type, and access control rules can be applied consistently. In semi-structured environments, the same sensitive value might appear under different keys or nested in different ways across records, which complicates detection and policy enforcement. In unstructured environments, sensitive information can appear anywhere in a text or image, which makes governance depend on content scanning, metadata control, and careful access restriction. Exam questions may hint at this by mentioning privacy, regulated information, or the need for audit trails, and those hints should trigger awareness that flexible structure increases governance effort. The practical takeaway is that data type classification is not only about analytics, it is also about risk management. Structure should be validated using samples, counts, and spot checks, because assumptions about shape are a major source of downstream errors. A sample review helps reveal whether keys are consistent in JSON records, whether text contains unexpected separators, or whether structured tables actually contain mixed formats and stray metadata. Counts can reveal anomalies, such as unexpected numbers of missing fields, duplicate identifiers, or sudden shifts in record length that signal a format change. Spot checks are useful because they catch the kind of subtle issues that statistics can miss, such as a header repeated mid-file or an address field that sometimes includes multiple values in one string. Exam scenarios often describe mismatches, parsing errors, or inconsistent totals, and these are frequently rooted in structure assumptions that were never verified. A candidate who thinks in terms of validation steps is more likely to choose answers that protect quality and reduce rework. A three-bucket sorting habit is a simple mental tool that keeps these ideas usable under time pressure. The first bucket is structured tables, where fields are consistent and ready for direct filtering, joining, and aggregation. The second bucket is semi-structured records like JSON, where keys and nesting provide labels, but mapping decisions must be made to create consistent representations. The third bucket is unstructured content, like text, images, audio, and video, where meaning must be extracted into features before quantitative analysis can begin. This habit is not a rigid rule, but it gives the brain a quick first classification that guides what methods are reasonable and what risks to anticipate. When the classification is correct, the rest of the decision tends to flow naturally from it. To conclude, structure classification is a high-yield skill because it determines what analysis approaches are feasible and what governance risks must be managed. Structured data fits fixed rows and columns and supports direct querying. Semi-structured data, like JSON, uses tagged flexible fields that require mapping. And unstructured content, like text, images, audio, and video, requires extraction into features before it behaves like a dataset. Search and analysis methods differ across these types, and a customer profile example shows how the same business information can travel through all three, changing how it must be stored and interpreted. Validation through sampling, counts, and spot checks protects quality, and governance becomes harder as flexibility increases because sensitive information is less predictable. One useful practice choice is to pick one dataset encountered today, state which bucket it belongs to, and say aloud the first risk that classification implies, because that habit makes structure recognition automatic and exam-ready. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.